Good afternoon, everyone. So today we will see numerical differentiation using central difference formula. So first we will see Stirling's formula, Stirling difference formula, and then we will discuss Bessel's central difference formula. Okay. So first we start with Stirling's central difference. So we will derive. So derivatives using Stirling okay. So first we will start with Stirling central difference table. Okay. So today we will study the derivation of numerical differentiation using Stirling's difference formula. Okay. So again, if a function f of x is equal to y is given, and you have to find the value of dy by dx or second derivative or higher derivative, okay, at x is equal to a certain value of x. Okay. Let's say at x0 and x0. And let's suppose this is x, y. So 1, 2, 3, 4, 5. Minus 1, 8, 0, 5, and 7. Okay, so these values are given for x and y, and we have to find the value of dy by dx in the middle of the table, that is at x is equal to 3. Okay, so whenever you want to find the value of dy by dx derivative dy by dx in the middle of the table, we normally use Stirling central difference formula or Bessel's central difference formula. Okay, so first we will derive the equation of dy by dx, formula of dy by dx using Stirling central difference. Then we will derive using Bessel's central difference formula. Okay, so where we will use this when you have to find the value of dy by dx or any derivative of the given function in the middle of table. So we will apply this formula. Okay, so you should know where it will be applicable. So where we have to apply this formula. Okay, so by Stirling's central formula. So we have seen this in last class. Okay, so y p is equal to y naught plus del y minus 1 del y minus 2 divided by 2, okay, plus, so this is p times and p square by factorial 2 del square y minus 1 plus p square minus 1 divided by factorial 3 del q minus 1 del q minus 2 divided by 2 plus p square minus 1 by factorial 4 del square y minus 10 to the power 4 y minus 1. Okay, so we have derived this formula in the last class. So by Stirling's central difference formula, we have yp is equal to y naught plus p del y minus 1 del y minus, sorry, this will be 0 divided by 2 plus p square by factorial 2 del square y minus 1, then p square minus 1 divided by factorial 3 del q minus 1, and del cube minus 2 divided by 2 plus p square minus 1 upon factorial cube del 2 over 4 y by 2. Okay. So what we need to find, we have to find dv by dx. Okay. So numerical differentiation of any given function and higher order of this derivative. So we will differentiate this equation with respect to p. So here variable is p. So this will be y. This will become 0. Differentiation of p is 1. So we will get this divided by 2 plus this is p square. So this will be 2p divided by factorial 2 del square by minus 1. This is p square. Okay, so it can be written as p square into p. So this will be 2p minus p cube. So differentiation of p cube is 3p square minus 1 divided by factorial p del cube y minus 1 plus del cube y minus 2 with 2. This is p to the power 4 minus p square. So differentiation of p to the power 4 is 4p cube minus 2p divided by 4 factorial del to the power 4 y minus. Okay. So on differentiating above equation, you get this value. Okay. So again, p is equal to x minus x naught divided by. Okay. So what we need to find that is dv by dx. Okay. We are deriving the value of dv by dx, but here it is dy by dp. Okay. So we will multiply this by dp by dx. So we will get dv by dx. Okay. So differentiating this with respect to x, so dp by dx will be equal to differentiation of x with respect to x is 1. This will be 0 divided by h. So this will be 1 upon h. So we have did this earlier. Now when we are finding the value of dv using Newton's forward and backward difference formula. So dp by dx is equal to 1 upon h. Okay. So dy by dp multiplied by dp by dx. So I am multiplying this equation by dp by dx. So this will be equal to. So this will be 1 into h. So dp by dx is 1 upon 1 into h, and this del y minus 1 plus y naught divided by 2 plus this will become p by 1. Okay, del square y minus 1 plus 3p square by factorial 3 is 6 del cube y minus 1 plus y minus 2. This will be p cube divided by p square divided by factorial 4 del to the power 4 y minus 1. Okay. So del p will be cancelled out. So you will get dv by dx. Okay. So you should know how to derive this formula. In examination, we generally ask to derive the numerical differentiation formula for Stirling's difference using Stirling central difference formula. Okay. So now we have to find the value of dv by dx at a certain value of x. Okay. So let's suppose we have to find the value of dv by dx at x is equal to x naught at any certain value of x. Okay. So we have to put x is equal to x naught. So here what we have p is equal to x minus x naught divided by h. Okay. So here x is equal to x naught. So this will be 0 divided by h. So this will be 0. Okay. So when x is equal to x naught, obviously p will be equal to 0. Okay. So substituting x is equal to x naught, so p become 0 in this equation, so what we get, so dv by dx at x is equal to x naught will be equal to 1 upon h. So this term is independent of p, so this will be del y minus 1 plus del y naught divided by 2. Okay. Plus, so this is p dependent term, p is 0, so this will become 0. Okay. So this term will be equal to 0. Here, this term will become 0 and this will be 1 minus upon 6. So this will be minus 1 upon 6 and this del q y minus 1 plus del q y minus 2 divided by 2 plus again pq and 2p. If we put p is equal to 0, this whole term will become 0. Okay, and then we get third, that will be 1 upon 30 del to the power 5 then minus 2 plus del to the power minus 3 divided by 2. So, okay, so you will get this formula. Okay. So this is dv by dx at x is equal to 0, 1 upon h del y minus 1 plus del y naught upon 2 minus 1 upon 6 del to the cube del minus 1 plus del cube y minus 2 divided by 2 plus 1 upon 30 del to the power y minus 2 plus del to the power 5 y minus 3. So even difference values are absent here. Okay. So this is the value of differentiation dv by dx using Stirling's difference formula. Okay, and similarly we can find for higher order. So for dv by dx, so second derivative at x square will be 1 upon x square. So del square y minus 1 minus 1 upon 12 del to the power 4 y minus 2 plus 1 upon 90 del to the power 6 y del minus 3 minus 8. Okay, so this is the value of second derivative using Stirling's formula. Okay, so you have to remember this formula to find the value of dy by dx and this dy square by dx square for when you need to find this derivative in the middle of the table. Okay, so this is by using Stirling's difference. Okay, so we have derived the value of dy by dx using Stirling's difference formula. Okay, so this is the derivatives, value of derivatives using Stirling's difference formula. So you have to remember this formula. Okay, so we will solve one numerical based on this. Okay. So now we will solve example based on Stirling's difference formula derivative. A sliding machine. Moves along a fixed straight rod. distance x centimeter along rod is given below for various value of the time is. Okay. So here distance in x centimeter and for the time t seconds is given. Okay. So find the velocity. Find the velocity of the slider. So there is a slider which moves along the fixed rod, okay, and its acceleration when t is equal to 0.6. Okay, so you have to find velocity of the slider and its acceleration at t is equal to 0.3 second. Okay, so here distance is given and time is given. Okay, so if you differentiate difference with respect to time, you will get velocity, and if you differentiate this velocity with respect to time, you will get acceleration. Okay, so this is the application of this Stirling's difference formula. Okay, so table is given. So t is given as 0, 0.1, 0.2, 0.3, 0.4, 0.5 and 0.6. Okay, so value of t is given in seconds. Okay, so in seconds, and value of x centimeters in distance is 13.13, 13.62, 32.87. In the meanwhile, please calculate the value of p. Okay. This is 33.64, 33.95, 33.81 and 33. Okay, so these are the values of t and x in centimeter. Okay, so there is a slider, so there is a rod, so this is a rod and there is a slider, okay, so which moves along this rod. Okay, so you have to find the value of the velocity and acceleration of this slider. Okay, so this is slider, so which is sliding, and this is fixed rod. So this is sliding on this fixed rod. Okay, so you have to find the value of velocity and acceleration. Okay, so we have to find the value of p. Okay, so we have to find at t is equal to 0.3 seconds. Okay, so here this value t is equal to 0.3 second. So this will be our t. Okay, so here corresponding value of P will be 0. This will be minus 1, this is minus 2, and this is minus 1. This will be 1, 2, and 3. Okay, so we have to find the value of velocity, that is dx by dt, at middle of the table, that is at t is equal to 0.3 second. So corresponding to this will become our x naught, okay, and this will be t. So this will be x naught minus 0.3 divided by 0.1 gives you 1. So this will be minus 2 minus 3. This will be 1, 2, and 3. Okay. So we need to find the differences. Okay. So this is del. So difference of these two, then difference of these two, difference of these two, these two. Okay. So first difference is 1.49. This is 1.25. So again we have to prepare the difference table. 3 1 minus 4 1 then minus 5. Okay, so this is our x first difference. Then we go with second difference. Del square x. So this will be minus 0.24. This is minus 0.48. This is 0.46 minus 0.45. Difference of these two is minus 0.4. Okay. Then third difference. Difference of these two, and these two. So this is minus 0.24, 0.02, 0.01, and 0.6. Then fourth difference. This minus this minus this, and this minus this. This is 0.026, 0.26, 0.01, 0.01. Fifth difference. So this minus this, and this minus. So this will be 0.027, and this will be 0.0. Difference. So this will be okay. So now we have to apply the formula of dv by dx. So here it will be dx by dt, in order to find the velocity. So why we are using Stirling's formula? Because we have to find the value of derivative, that is dx by dt at the middle of the table. Okay. So you should know where we have to apply this Stirling's formula. Okay. So here we have to find the value of dx by dt at t is equal to 0.3. So this is in the middle of the table. So we are using Stirling's formula. Okay. So this is equal to del minus 1 by del naught divided by 2 plus 1 upon h. 1 upon h plus minus 1 upon 6 del y minus 1 del q del y minus 2 divided by 2 plus 1 upon 30. So we have derived it here. So by Stirling's formula, okay, by Stirling's formula for derivative, we have this formula. So this is what is this equal to? This is equal to velocity. So velocity is equal to dv by dx, and d is equal to 0.8 second. This will be equal to 1 upon h. So we have to find the value of del y minus 1, del y naught, okay, and other derivatives or derivatives. Okay. So this is p, that is minus 3. This will be corresponding x minus 3. This is x minus 2. This is x minus 1. This will be x naught, x1, x2, x1. Okay. So you have to take this as x minus 3. Okay. So first write t and x, and in the middle you should write p. Okay. So we have to find the value of velocity at t is equal to 0.3. So this term will become t naught. Okay. Corresponding to this, value of p will be 0, and this will be the corresponding value of x naught. So this will be x minus 1, x minus 2, and x minus 3. So this value will be del x minus 3. This will be del x minus 2, del x minus 1. Okay, so here this will be y. This will be replaced by x. So this is dx by dt. So this will be x. X0 minus 1 minus 2 x minus 2 x minus 3. So we have to find x minus 1, then x minus 1, and this is del x0. Okay. Then again this will be del square x minus 3. This will be del cube x minus 3, del to the power 4 x minus 3, del to the power 4 x minus 3, and del to the power 6 x minus 3. Okay, so you should know how to write this difference. Okay, so this will become del square y minus 2, del square x minus 1, and del square x0. Okay, so this term will be del cube x minus 2, del cube x minus 1, del cube x0, del to the power 4 x minus 2, del to the power 4 x minus 2, del to the power 5 x minus 4. Okay. So this is very important, how to write this difference. Okay. So what we need first, del x minus 1. So this is del x minus 1. So this will be del x minus 1. So what is h? H is, this is 0, 0.1, 0.2, 0.3, 0.4, 0.6, and 0.6. So this is quite clear. H will be 0.1 minus 0. So this will be 0.1 divided by 0.1 into del x minus 1 is 0.77 plus del x naught. So del x naught is 0.31. Okay, so this value is 0.31 divided by minus 1 upon 6. Then the even differences are absent. Only odd differences are present. So del cube x minus 1. del cube x minus 1 is 0.01, this value. So 0.01 del minus 2, del cube is 0.02 divided by plus 1 upon 30 del to the power x minus 2, del to the power x minus 2 is this 0.02, and del to the power x minus 3 is minus 0.7, minus 2.7 divided by, okay. So we have substituted these values. Okay. So on solving this, you will get 5.333 meter per centimeter per second. So this is your velocity. Okay, so this is the approximate value of velocity using Stirling's formula. Okay. So first, what you should know. So this question is given like this. Value of t is given 0, minus 1, minus 2, minus 3, minus 4, minus 6 and minus 6, and corresponding value of distance is given. You have to find the value of velocity at t is equal to 0.3. So obviously it is lying in the middle of the table. Okay. So whenever you have to find the value of differentiation derivative at the middle of the table, we use Stirling's formula. Okay. So first you should know which formula has to be applied to the given formula. Okay. So here we use Stirling's formula. So this is Stirling's formula. So you need to find del x minus 1, del x naught, del cube x minus 1, del cube x minus 2, del to the power x minus 2 and del to the power x minus 3. Okay. So now we have to prepare this difference table. Okay. And from here, this table you can find the values of the differences. Okay. So this is del cube, and so these are the values. Okay. So this is del x minus 1, del x naught, del x minus 1, del x naught, then del x minus 1 and del cube x minus 1, del cube x minus 2, del to the power x minus 3 and del to the power 5 x minus 2. Okay. So we have substituted this value and velocity is equal to 5.33. Distance is given is in centimeters, so this will be centimeter per second. Okay. Then we have to find the acceleration also. Okay. So acceleration A will be equal to dx square by dt square. Okay. So now formula will be changed. So we have to apply second derivative formula. Okay. So this is 1 upon x square del square x minus 1 minus 1 upon 12 del to the power 4 x minus 2 plus 1 upon 90 del to the power 6 x minus 3. Okay. So this is formula of second derivative. 1 upon x square del square x minus 1 minus 1 upon 12 del to the power 4 x minus 2 plus 1 upon 90 del to the power 6 x minus 3. Okay. So h is 1 upon 0.1 whole square. Okay. Now this is del square minus 1. Okay. So this is del square minus 1. Okay. So now these even derivatives will be differences will be used. So it is minus 0.46 minus 12 into del to the power x minus 2 del to the power x minus 2. This is minus 0.01 1 upon 9 del to the power 6. This is On solving this, so A is equal to dv by dt is equal to dx square by dt, okay, is equal to minus 45.6 centimeter per second square. Okay, so you can find the value of expression. This is dv by dt del x d square by dt square is equal to this one. So substitute these values of differences. Okay. So any doubt? Okay. So mainly you have to remember all these formula. Okay. So you are studying various type of difference formula. Okay. So you need to remember all these formula. All formula are same. Okay. So it's your job. You have to learn this formula. Okay. Now you can find this derivative by using second method, that is Bessel's formula. Okay, so you can find the value of derivative using Bessel's formula as we done for Stirling's formula. So both the methods will give approximately same answer. Okay, so if in the question it is not mentioned which particular formula has to be applied, so you can use any formula. Okay, you can go with Stirling formula or you can use Bessel's formula. It's up to your choice. Okay, if it is given in the question, use Stirling, so you have to use Stirling's formula. Okay, so we will derive the formula using Bessel's central difference formula. Derivative using Bessel's difference. Okay. So y is equal to y naught plus p del y naught square plus p minus 1 by factor into del square y minus 1 plus del square y by 2 divided by 2 plus p minus half p so divided by factorial 2 del cube. So in the last class we have studied about Bessel's central difference formula. So this is central difference formula using Bessel's formula. Okay. So again we have to find the derivative. Okay. So we will derive differentiate it with respect to p, and again we will find first we will find dy by dt. So differentiate this above equation with respect to p, then we will find p is equal to x minus h naught divided by h, then dp by dx which will be 1 upon h. So again dy by dp multiply this equation by dp by dx, we will get this formula. Okay, and put p is equal to 0 and x is equal to x naught. Same step as we done for Stirling's formula. So I am not deriving it, I am writing its direct formula. Okay, so you can do it yourself. So differentiate this equation with respect to p, then dp by dx will be 1 upon h, and if you multiply this equation by dp by dx, you will get du by dx, and substitute the value of p and when x is equal to x naught, so you will get the value of dv by dx. Okay, so I am writing directly dv by dx, and any certain value of x is equal to x naught is equal to, so 1 upon h del y naught minus 1 upon 2 del square y minus 1 plus del square y naught divided by 2 plus 1 upon 12 del cube y minus 1 plus 1 upon 12 del to the power 4 y minus 2 del to the power 4 y minus 1 divided by 2. Okay, so this is the value of derivative using Bessel's central difference formula. Okay. So now we will write, this is higher values are minus 120 get to the power 5 minus 240 get to the power 6 minus 3 get to the power 6. So this is the formula, and we can find also the higher derivative, higher order derivative. Okay, so y square on x square at x naught which is square del square y minus 1 plus del square divided by 2 minus r del cube y minus 1 minus 12 into the power 4 y minus 2 plus del to the power 4 y minus 1 divided by 2. Okay, so this is value of dv by dx using Bessel's central difference formula. Okay, so Stirling's difference formula and Bessel's difference formula derivative that we will use when we have to find the value of derivative at middle of the table. Okay, so you have to remember this formula. Okay, so now we will solve one problem based on this. A rod is rotating in a plane. The following table gives table gives the angle through which the rod turned turns for various values of time t. So a table is given with respect to theta, which is in radians, and time t. What you have to find? So calculate angular velocity and angular acceleration and angular acceleration. Okay. Of the rod when t is equal to 0.6 second. Okay. So in previous question we had find the value of velocity and acceleration. Here we are finding angular velocity and angular acceleration. Okay. Theta and t is given. Okay. So value of t is given 0, 0.2, 0.4, 0.6, 0.8, 1.0 and 1.2. Okay. And theta, value of theta is given as 0, 0.12, 0.49, 1.12, 2.0, 3.2 and 4.67. Okay. So value of theta in radians. Okay. And time in seconds in given. Okay. So there is a rod. So rotating in a plane. So the following table is given for theta and time t. You have to find angular velocity. Omega is equal to d theta by t at t is equal to 0.6. Okay. So looking to the table, 0.6 is lying exactly in middle of the table. Okay. So again we have to use central reference formula. Okay. For that we have derived formula of derivative using Stirling's and Bessel's central reference formula. So here we will use Bessel's reference formula. Okay. So how to decide which formula has to be applied? Okay. So here we have to find the value of angular velocity and angular acceleration alpha is equal to d omega minus dt, that is del square dt. Okay, at t is equal to 0.67. So it is given in the question. You have to find the value of omega and alpha at t is equal to 0.6 seconds. Okay, so from the table, it is quite obvious. 0.6 is lying in the middle of the table. Okay, so this will be T naught. Okay, so correspondingly, this will be x naught, sorry, theta naught. Okay, and we will write P, so this will be 0, minus 1, minus 2, minus 3. 1, 2, and 3. Okay, so you have to prepare this table like this. Okay, so again we have to find the difference table. So it is quite mandatory to draw the, so prepare this difference table. So first difference will be del theta. Okay, so this will be difference of these two, 0.1 to minus 0 is 0.2. Difference of these two. So this is 0.37. This is 0.63. 0.9. 1.18. 1.47. Then second difference, delta square theta. So difference of these two. Okay. This is 0.25, 0.26, 0.27, 0.28, 0.2. Okay, so 0.24, 26, 27, 28, 29. So then will be same. Del to the power del q. So this will be difference of this two is 0.01. Difference of this two is 0.01, 0.01, and 0.01. Obviously, both difference will be 0. Difference of this two is 0. This is 0, and this is 0. So this is our difference table. Okay. So now we will write the formula. So we have to find the angular velocity. Okay, so d theta by t. Okay, omega is equal to angular velocity. So d by theta is 1 upon h del theta naught minus 1 upon 4 del square theta minus 1 plus del square theta minus 2 plus 1 upon 12 del to the power q minus 1 plus 1 upon 24 del to the power 4 y minus theta minus 2 and then to the power 4 theta minus. So by Bessel's formula, so we can find the angular velocity by using this formula. Okay. So what we need, del theta naught. Okay. So first we will del theta naught. Okay. So this is p minus 1. So this will be theta minus 3, theta minus 2, theta minus 1. This is theta naught. This is theta 1, 2 and 3. Okay, so this will be correspondingly del theta minus 1, this will be del square theta minus 3, del cube theta minus 3, del to the power 4 theta minus 3. Okay, so the first term of the difference will be theta minus 3. Okay, now this will be del theta minus 2, del theta minus 1, del theta 0. So del theta 0 is 0.9. Okay, so this is del theta 0. So first term, so omega is equal to del theta by t. What is h? H is 0.4, 0.6, 0.8, 0.1. So it is 0.6 minus 0.4, 0.2. This is divided by 0.2. Del theta naught is 0.9. Okay. Minus 1 upon 4. Del square theta minus 1. So this is del theta minus 3. Del square theta minus 2. And this is del square theta minus 1. So what we need? Del square minus 1. So this is 0.27 and del square minus 2. So this is del square minus 2. So plus 0.26 plus 12 del cube theta minus 1. Del cube theta minus 3, del cube theta minus 2, and this will be del cube theta minus 1. So this is 0.1 into 0.1, so 0.1 plus 0. Okay, so del to the power 4 is 0, so this will be 0. Okay, so on solving this, you will get 3 point omega is equal to d theta by t is equal to 3.8 radian per 3.167 or approximately is 3.8 radian per second. Okay, so first you have to prepare this difference table. Okay, then you have to write the Bessel's formula. Derivative of Bessel's formula is 1 upon h del theta naught. Okay, so this is value of t, this is value of theta. You have to find at t is equal to 0.6. So this will become t naught. Okay, so this will be value of p and this will be theta naught correspondingly. So this is minus 1, minus 2, minus 3 value of p. So this will be theta minus 3, del theta minus 3, del square theta minus 3, del cube theta minus 3, and del to the power 4 theta minus 3. Okay, so correspondingly you can find the values of theta minus 2, theta minus 1, and theta minus. So this is theta minus 0, then theta minus del square theta minus 1, del square theta minus 2. Okay, then del cube theta minus 1, and del, these values are 0, no need to find. Okay, and also you have to find the value of del square, that is alpha. Okay, so we will write the formula so alpha is equal to d by dt is equal to 1 upon h square del square theta minus 1 plus del square theta naught divided by 2 minus half del q theta minus 1 minus 12 del to the power 4 theta minus 2 plus del to the power 4 theta minus. Okay, this is the value of angular acceleration. Okay, so what is h? H is 0.2, so this will be 0.2 whole square. Okay. Del square theta minus 1. Del square theta minus 1 is 0.27 plus del square theta 0. So this is del square theta 0. This is del square theta 0. This value. This is 0.28 divided by 2 minus 1 upon 2. Del q theta minus 1. Del q theta minus 1 is 0.01 minus 4 del to the power 4 is 0. Okay. So on solving this, you will get 6.75. So alpha d by d is equal to d square by 2. This is the value of angular acceleration. Okay. So this is all about derivatives using central difference formula, which uses Stirling's difference formula and Bessel's difference formula. Okay. So where to apply this formula? When you have to find the derivative at the middle of the table. Okay. So any doubt in today's class, you can ask. So one question will come using this Stirling's difference and Bessel's difference formula. Okay. Okay. Thank you, class.